Hello everyone, this is Syd+Youki, Syd-OCI Introduction to a Secure Container Runtime for Linux. I'm Ali Polatel, an Exarvo developer. Before we start, here is some information about Syd. You can take a photo if you want. We have a CTF game if you want to play, and check out Syd. And we have extensive documentation as man pages. And if you have any questions that you cannot ask here, just pop up on IRC or Matrix and find me. I'm usually there. Yeah, and before we start, again, I should be perfectly honest. I know next to nothing about containers. And me having written a container runtime was a bit of an accidental thing. And it wouldn't have been possible without the great work of the Youki developers, which they told me they've been watching. So I want to give a round of applause to Youki developers. Thank you. So what's Youki? I got this from their manual page. It's an implementation of OCI runtime spec in Rust. So it's basically runc written on Rust. You can think of it like. And this is how it's pronounced. It's a Japanese word meaning cheerful or merry or hilarious. And they have their reasons for picking Rust here, which is Rust is one of the best languages to implement the OCI runtime spec. Many very nice container tools are currently written in Go. However, the container runtime requires use of system calls, which requires a bit of special handling when implemented in Go. I'll speak a bit about this later when comparing Rust with Go. And so writing container runtime in Rust is typically a bit easier than writing in Go. So what is Syd-OCI? Syd-OCI was basically a friend of mine coming to me and telling me, why aren't you making Syd a container runtime? And as I said, I know nothing about containers. And I was like, is there anything that I can use for this? And then I came across Youki. For a brief introduction, Syd is a sandbox with the motto to make sandboxing as easy as text searching is with grep. And for those who want to know more, watch my talk in the morning if you haven't watched it already, or go to our manual pages and check it out. And what Youki people have also done very nicely is that they have actually written libraries, not just the binaries. So they provided the Rust environment very nice libraries so everyone can go out and write their own container runtime, which is what I did basically. Syd-OCI was just a weekend's work to replace the default executor with a special executor for Syd. And basically, Youki sets up everything, and in the very last stage, before you execute the binary, we set up the Syd sandbox, and you execute it inside the sandbox. There came Syd-OCI. Syd-OCI is a secure container runtime for OCI-compliant Linux containers. It's GPL3, and it's forever free. And this is how you install it. You need to pass features OCI when you are building Syd. It's not enabled by default. And we have Pandora for learning mode, which I will try to display in a bit. And then it's just a matter of passing runtime Syd-OCI to Docker or Podman or whichever container engine you're using. It should just work as it's OCI compliant. And how do we do this? This is a bit of how Syd-OCI works, and basically the idea is you have a sandbox policy and you load this policy into Syd at startup. You can also configure the sandbox as you go, which I'll also display to you. And this page goes on to explain how this file is picked. And in the last you will see if you have no files to configure, then Syd will load this built-in OCI profile, and this is designed to be used with Pandora and learning mode. So you can run your container first, check its behavior, create a profile, and enforce that profile, and then use Syd like that. And I'll here give a brief comparison with gvisor, because gvisor seems to be the most commonly used sandbox these days. And yeah, so what's different in Syd-OCI than in gvisor is, first of all, it's Rust versus Go, which is a completely different talk subject. I will not go deep here. However, I will explain my part of it in writing a sandbox in Rust. Rust has idiomatic and strict error checking, which really helps when you're writing safe code. Rust has no garbage collection. Again, this is a subject for a different talk. I will not discuss whether having a garbage collection is good or not. But when writing that low-level code, having less side effects in code actually allows directly for more refined per SID thread seccomp PPF filters, for instance. And we have in SID, SID is a multi-threaded process, and each process has a different name, and they have their different duties: SID main, SID emu, SID monitor, and SID interrupt, and so on. And each of these threads confines itself on its own based on their duties and so on. And what else is different? We have position-independent executables. You cannot, as far as I know to this day, build Go binaries position-independently. So typically a compromised gvisor is far less severe than a compromised SID. And moreover, SID also enforces position-independent executables. So you cannot execute non-pi binaries under SID unless you actually set at startup to allow them. Then SID set AT secure auxiliary vector like AppArmor does, which means you don't get to load LD preload or LD library path or other shenanigans. And we have SegvGuard. Again, I dived into this a bit in my last talk. And we have mitigations for SIG return-oriented programming and return-oriented programming, which gvisor doesn't have. And you can go ahead and read about this in the SID7 manual page. It's all documented nicely. And Syd-OCI is noticeably faster than gvisor. I'm not going to give any numbers because I don't really have clean benchmarks, honestly, but typically Syd-OCI does less isolation, so it has less overhead. I'm not claiming they are doing the same thing and I'm doing it much faster. No. gvisor has their own memory management, their own network stack, and so on, and that's why they have more overhead. For those who are interested, they can go to the Git repo and check out the benchmarks. Typically, the numbers are in like for SID, it's 10 to 15% overhead in my measurements, and for gvisor, it varies between 40 to 70%. And gvisor has layered security, which is really impressive, and we have something similar, and I want to give an example here, which we had in effect in real time very recently. With SID, you can also use landlock as an additional layer, and landlock has recently had a break. People who are interested can go to the CD and look for it. The break was essentially you would execute a malicious KCTL call, and then the landlock was broken and you could open any path. But under SID, because the malicious KCTL call and the open happens in different processes, SID emu processes are responsible for actually running the system calls. SID does not continue the system call in the sandbox process after the access check, and as such is not vulnerable to time of check to time of use. And if you need more fast, go fast, unroll my loops. For every mitigation in SID, we have an allow unsafe clause that you can use to disable that mitigation. There is like maybe 30 of them right now, and the three most important that come to mind when you want performance are these. By default, SID will run processes with low priority, and we use ptrace, and you can disable all of these if you want. And as in, SID is a general purpose sandbox. There is no way to write a one-size-fits-all type of sandbox. It's typically impossible, but what we do is, for every mitigation, we have an allow unsafe clause, so you can disable it and use it for your own case. And now I will try to display it a little bit. I don't have a really demo yet, but what I have here is, let me quickly show you. Can everyone in the back see what's written? Yes, that's great. Okay, so this should be a lib container file here. Yeah. So this is how you configure OCI for Podman, and I'm going to run a rootless Podman here now. With run, hopefully, yes, this one. So, as usual, there is nothing special. We are running in SID, and the way you learn this is through dmask. So you get some fancy Pink Floyd lyrics. And then right now the sandbox is running in warning mode. So every warning is put into demask. You can also make it right to standard error or do something else, and just, it's basically lines of JSON. You can feed them to Pandora afterwards, however you want. And here I will just basically show you, just download the page, and then actually, hang on, yes. This is going to be a little tricky, but let me see. I want to, wait, yes. I'm going to copy the Pandora static binary into it. This will be much more easier when distributions have Pandora and Syd packaged, of course, but just for now, we have Pandora in the container now, and I'll tell Pandora to just go through the syslog and create me a profile. This takes a bit because it is going to verify the checksums of the binaries, but not too much, hopefully. Wish me luck. Come on. Okay, so the idea is we have all the sandbox logs, and then we take them and create a, okay, let's make this actually a bit faster. It did, okay. Anyhow, so it generated a profile. I will quickly show you the profile. So these are what we have done so far. We have downloaded a web page. As you can see, these are there. We did some terminal IOTLs and so on. And everything is in here. And now you can actually load this in runtime dynamically into Syd with some fancy command that we have here. Dev Syd is the virtual path that you use. Load is used to load a file descriptor. It can be any descriptor. It doesn't matter. And before we do this, let me quickly show you the state of the sandbox. Again, as you can see right now, the default action is warn. So it's going to just warn and do nothing. So now we are going to load. Let's go. Yes. As you see, we have loaded this file into Syd. And now if I try again, you'll see the rules are actually loaded into Syd. And this is still not enforced. To actually enforce, you need to do a final bit to load the enforced profile. And now, if I try to download the same web page, it's going to work. But if I try to download another web page, it's going to deny me. And we can see this via the sandbox logs, as you can see. And Syd gives you tips. So let's go ahead and try to download leeches by allowing it one by one, which takes a bit. Again, here I wanted to show how to configure the sandbox dynamically. You can do this all statically at startup as well. Let's try again. Okay, this is another one. So let's allow this. It will take a bit to allow all of them, but so basically you can do this one by one. You can load a file descriptor as we did before. Let's get now. Okay, we are coming close. So now we are going to allow this. And also 443. And we should be good to go. See, it downloaded. As you can see, you can configure the sandbox from within sandbox as well. So this way you can make a step-by-step OpenBSD pledge like a confinement as well. And this is all I have. Thank you. If you have any questions, I can take now. No questions? Yes, please.
How complete is it how complete is the implementation compared to gvisor?
How complete is the implementation compared to gvisor is the question. First of all, Syd has been used for 16 years as the default sandbox of Exarbo, and Exarbo has package testing by default. So we run all tests under Syd box. Any test that passes without the Syd box but not without Syd is considered a sandbox bug. And over the years, we have fixed a lot of things. Complete is a big word, but you can say Syd is stable. You can say Syd gives you a stable Linux ABI. So yeah, and this day you can use it as a general purpose sandbox from sandboxing Nginx to sandboxing Firefox or any similar workload. Yeah. Any other questions, please? Okay, looking around. I suppose not. Wasn't that interesting, huh? Well, read the manual pages, you'll be impressed, I'm telling you. All right, waiting a bit more. Yes, please. Please wait the mic.
Hello. Yeah. So I have a question because right now, of course, it's going to be a question about AI. Right now, we have some problems like trying to sandbox machine learning workloads, and yes. Some teams, some organizations are doing something like running clusters with full access to the internet because why not? Mm-hmm. Of course, you can create a proxy and limitations, but still, there are options that you try to run the images of or models. How can we use this setup to yes. mitigate this kind of attacks, especially when some models try to load the malicious code from the internet and so on? Is it possible with this tool?
Yes, it's possible. First of all, it is possible to sandbox AI workloads with Syd. We have what's called IOCTL sandboxing, where you can sandbox rather than paths, you actually sandbox IOCTL requests. And maybe I can quickly show you here in the where is it? Oh, I lost it. Nice. Okay, anyway, it's in enforced mode, so it won't let me. But I was going to show you the IOCTL requests. You can, even in learning mode, it will learn which IOCTL requests are done to the whatever device, DRI or AI, whatever, and then it will give you a list of all these requests, and then with that you can just run your AI workload under Syd. And then what you are limiting is basically up to you. Are you allowing it network? Do you want to run it in a network namespace? Again, Syd is a general sandbox. You are supposed to build the actual sandbox with your configuration, but this is very much possible. You can tell it to go to some IP addresses, but not others, and so on. This is possible, yes. Thank you for the question. Yes, please.
But what about the workloads on the GPU? How do you handle this? When, for example, NVIDIA stuff?
Yes, it's basically the same thing. GPU access is typically done through IOCTLs. And what gvisor does is actually, gvisor keeps a list of NVIDIA IOCTLs by version. Right? So in this way, it's easier for you to use gvisor. Syd doesn't give you that. But Syd gives you a way to do this. So you can run it under learning mode and quickly get the request numbers. These are basically random looking numbers that you have to allow for the GPU access. And that's how it works. Yeah, yeah. Mm-hmm. Sure. Any other questions? Looking around. Mm-hmm. All right. Thank you, everyone, for watching.